I have the answers and explanations for homework 2.A.3, 4.8, 4.12, 4.18, 4.70, 12.12, and 12.06. The first one had 3 boxes, 4.8, had 3 boxes and asked which one would show the proper picture of sodium chloride in water. First of all, we wanted to see one where the sodiums and chlorides were separate, but also the chloride, the larger ion, should be next to the hydrogen side of water, and the sodium should be surrounded with waters with their oxygens facing towards the sodium. So the one that showed that picture the best was letter C. 4.12 was asking which of the forms of sodium chloride will will conduct electricity. Solid sodium chloride will not conduct electricity, even though it has positive and negative ions. The ions are stuck in a crystal and can't move. So without mobility, they will not conduct electricity. In molten, letter B, molten sodium chloride, melted sodium chloride, the ions can move, and so they will conduct electricity. And also in dissolved or aqueous sodium chloride, they can also move. And so either way, as dissolved or molten, they will conduct electricity. 4.18 is asking about pictures again. They had 4 pictures, A, B, C, and D, and they wanted to know which one would be appropriate for showing magnesium chloride mixed with potassium hydroxide. And even though magnesium chloride and potassium hydroxide are both soluble, when mixed, the ions of magnesium and hydroxide will form an insoluble combination. And so I picked the one that had MgOH2 written as a single formula and solid, and then the KCl, the potassiums and the chlorides, will actually remain to be separate as K plus and Cl minus ions. And so the letter B is the one that shows that the best. 4.70. 4.70 is a problem involving a dilution problem. In dilution problems, we take advantage of the molarity 1, volume 1 equal molarity 2, volume 2 equation. Molarity 1 was 0.866 molar. Volume 1 was 25.0 milliliters. Molarity 2 is our unknown, and 500 milliliters is volume 2. We dilute the 25 milliliters to 500 milliliters. Dividing both sides by 500 milliliters, I get molarity 2 is 0.0433 molar. Okay, 12.12 shows the different carbon chain lengths of alcohols, and the smaller alcohols it shows are very soluble in water, but when the chains get long enough, then they become less soluble in water. And that's because the carbon chains, the hydrocarbon portion of the molecule, is nonpolar and as a result not very attractive to water, whereas the OH portion is attractive to water because it can hydrogen bond with water. And so short chain alcohols are soluble in water because they're more polar. Long chain alcohols are not soluble in water or less soluble in water because they are less polar or nonpolar. Finally, we have the hardest problem was the question involving concentrated hydrochloric acid. They gave us the percent HCl and the density of this concentrated hydrochloric acid and asked for the molarity. So this one you're going to have to get strategic with. You're going to want to assume 1,000 milliliters, since we know molarity is moles per liter. If we assume 1,000 milliliters, or 1 liter, then the 1,000 milliliter volume times the density, 1.19 grams per milliliter, will give you 1,190 grams of solution. Of that 1,190 grams of solution, 37.7% or 0.377 is HCl. So in other words, in the 1190 grams of solution, 448 grams are HCl. I change 448 grams of HCl's to moles, then I get 36.46, divide by 36.46 grams, I get 12.3 moles. And remember, it's per liter, so this is 12.3 moles per liter, or 12.3 molar.